takes us to another insightful panel discussion on challenges in EV battery swapping, battery prices, and RE based charging, which will be chaired by Mr. Shikhar Gupta. Requesting the panel chair, Mr. Shikhar Gupta, to please come up on stage along with Mr. Shashank Sathe, Mr. Prathamesh Patki, and Mr. Akshay Sasikumar. Mr. Shikhar Gupta is a seasoned professional in the field of energy and electric mobility, renowned for his extensive expertise in new solution development, strategy formulation, research insights, and business development. Currently, he serves as the director at PwC, where he plays a pivotal role in driving and supporting PwC's energy, automotive, and broader industrial product transition journey. Mr. Gupta is dedicated to identifying and creating new opportunities that benefit PwC's client. During his tenure at EY, spanning over a decade, Mr. Gupta honed his skill in crafting go-to-market and investment strategies for clients in various domains, including innovation, electric mobility, energy storage, and the broader power sector. His rich experience has led him to collaborate with clients across multiple geographical regions and sectors, including energy, government, and automotive. We are honored to have Mr. Shikhar Gupta here with us today, sharing his insights and knowledge. Let's give a round of applause for Mr. Shikhar Gupta and the panelists.
Thank you so much for the introduction. Good afternoon, everyone, and welcome to our panel. Now we have been joined by a distinguished set of panelists today, and over the next 20 minutes, our goal is to bring out a lot of nuances and insights around EV charging infrastructure. Now, we have heard a lot about this morning that there is no doubt that EVs are the future when it comes to transport electrification. But one of the backbone of that acceleration is charging infrastructure. So today, via the panel, we'll try and talk about battery swapping, where there is a lot of discussion around whether it's the right solution for India, and other forms of charging infrastructure technology and their use cases. But before I do that, let me introduce the panelists. So on my right, I have Mr. Prathamesh Patki. Now, Prathamesh serves as the Chief Engineer of Altigreen. He has more than 18 years of experience, especially in the embedded system development, and currently he's working within the R&D department since 2013. And prior to joining Altigreen, he played pivotal roles in core technology areas in organizations like L&T Aerospace and John Deere. So, Prathamesh, welcome to the panel. All right. On my left, I have Mr. Shashank Sathe. Shashank is the CTO at Magenta Mobility. More than 28 years of experience in the core technology and innovation domains. He's an expert in low-code, no-code frameworks, data engineering, and he has pioneering solutions in fintech, EV logistics, and solutions. And again, Shashank, through this panel, we will love to know your views around technology in the charging infrastructure, from your lens and what you have observed over the last several years. And then on my extreme left, I have the pleasure to have Mr. Akshay Sasikumar. He's the co-founder and CEO of 82 Volts Technology, which is an integrated EV technology company. Now, if you look at Akshay's background, he would like to see himself as a fusion of automotive engineer and business manager. And I think because of his passion for sustainable energy solutions, he founded the company along with other co-founders. And again, Akshay, we would love to know your views on how you are seeing the development of charging infrastructure in India. So with that, let's kick off. All right, Akshay, maybe my first question is to you. There is a lot of conversations around, and we are seeing a lot of development around charging infrastructure in India. But really the key question is, are we focusing on the right technology? Are we focusing on the right planning? Are we using the right technology when it comes to location mapping or GIS mapping and so many other solutions to actually implement that infrastructure? Can you comment on that, how you're seeing the current state, and where do you think we really need to focus on? Not just investments, but maybe the technology solutions.
Okay, great question. Today, India focuses on, I think, fast charging solutions in public places like highways, malls. That's what you're seeing most of the CPOs doing, right? But fast charging is actually not good for your car in the long run. If you can't always be doing fast charging for every cycle. So what India has to, slowly pivot into is create long parking scenarios and establish charging stations in those places. For example, the place you work, you're likely to be there for 5 to 6 hours or even more, right?
Right.
So you charge your car using an AC charger, you increase or you at least maintain your battery life, to say the least, right? That's one. Two is bring charging to your home, which, like you said earlier, will probably be plugged into your renewable energy installation at your home as well, right? So when you do that, you create a whole green energy cycle, as in generate your own energy and charge your electric car. It's a full green energy cycle. So today, what's happening is, because it's so early in the ecosystem, people need to get used to charging an EV. The whole refueling behavior has to change. Earlier, you used to go somewhere to refuel your vehicle. Now, wherever you go, you refuel your vehicle while you sit and do your work. So that behavioral change is very critical for the EV ecosystem to grow up. With respect to technologies, charging algorithms are changing. I'm sure the other two panelists will talk a lot about battery technology and how that is impacting charging algorithms as well. Cars are improving, grid is getting better. There are a lot of grid management companies which suggest to chargers on when you can charge, when you shouldn't charge, and so a lot of new tech is coming into the whole EV ecosystem, but it's still so early that I personally don't want to predict anything about what will happen, what's not going to happen.
That's fair, Akshay. All right. No, thank you so much for that perspective. So, just to continue that conversation, Shashank, if I may, ask you, like we just talked about battery swapping as a technology, right? And over the years, there is a debate at whether it is the right solution for the Indian market for a variety of reasons, right? To reduce the upfront cost, or to create a convenience. I think Pranjal just mentioned, nobody wants to wait for 6 hours, to fuel their batteries. So, can you comment on battery swapping as a charging technology, but after that, what are some of the other technologies that you really see are accelerating, the uptake of electric vehicles in India?
Okay, so to first off address elephant in the room, swapping in the current state in India is, I think we are probably, maybe 5-10 years away, right? It's a long way to go. The swapping has been tried out very early by Tesla, I think 1.5 to 2 years ago. They found it to be unviable at that point in time for the sheer amount of investments that were required for building the swapping infrastructure, the cost of storage of that battery, the logistics around moving of very heavy and potentially decaying batteries over a period of time for storage, and placement of these batteries in the right ambience environments. These were 4 or 5 environment and dynamics related challenges that were faced back then. Most of these exist even today. There are a couple of organizations and big organizations around the world who are trying this out. For example, in China, NIO is one, CAT L are another one, who are probably, I think these two are the most prominent ones, and both of these have got large deployments in most countries in Europe, right? So Sweden and all those green energy conscious nations have adopted or outsourced solutions from them. Now, there are lots of innovations happening within these spaces. Typically, CATL is assuring an 8-year / 800,000 miles warranty for the battery that they are putting in the car. It remains to be seen whether that actually is going to transfer into real life, and how does that extrapolation happens. But they are very keen on pushing battery as a service model. Same is the model with NIO as well. And I think the dynamics around these will again be dependent on how all of the logistics work out. In Indian mind space, I think we are still long way to go. Swapping, I have seen couple of videos and reels on Facebooks and Instas and all saying, some organizations and setups in Philippines and Thailand and all, plonk
That's
out,
correct.
batteries from their 2-wheelers and 3-wheelers and plonk new ones. That could be a remote possibility here to start off with. But car batteries themselves in its very nature are extremely heavy. Buses and trucks even more so. It is humanly impossible to lift and shift an automobile battery anything more than, that's the size of a 3-wheeler. So cars and truck batteries are humanly impossible to lift it by mind. So that, I think that's the challenge that we have currently, and that's the ground reality.
No, that's brilliant, Shashank. Thank you so much for bringing out that aspects because I remember, and I think we were just talking, right? A few years back, there was a big vision to make India the battery swapping capital of the world, and with all the right intent. I think the questions that you raised, that there is so much nitty-gritty of charging at ambient temperature of those batteries, the security, the maintenance, and really the customer experience, right? If I'm investing so much, would I? And I think you raised a very interesting point that someday I'm getting X, kind of a mileage, and the other day I'm getting X minus Y. Who's responsible for that? And am I ready for that experience? So thank you for that. So Prathamesh, if I may, come to you now. I think you have significant experience from a research and development perspective, but also Altigreen's into 3-wheelers, cargo vehicles, and from a logistics, industry perspective. Now, this is one of the fastest growing industry from an electrification of transport. What is your observation so far? How are you seeing your customers are currently meeting their charging requirements? And in your view, what is an ideal solution if we have to further accelerate this?
Okay. So that's what we deal with. We make 3-wheelers basically. So with our 3-wheelers, we always give. So as a part of mandatory requirement, we need to. I'm audible, right? Okay. So we need to give a slow charger, which is 3 kilowatt, which can be charged through any 15 amps plug point, which will charge our vehicle in about 4 hours. So that goes with, and that will keep going with each and every vehicle. So that is about the slow charger. So then we have some variants that already there is one variant which is with the fast charger, which can charge the battery in 15 minutes. So that is with one of our partners with their battery and their charging solutions, charging system, basically e-pump is what they call it. So already that we are producing those already and we are selling those. So that is 15 minutes charging. So the fast charging, again, that is for fast charging. And then the third variants which will start coming will also be fast charging based, but that will be by using some standard fast charging networks that are available. So right now for 2-wheelers and 3-wheelers, it is mainly, I think, GB/T DC001 charging, which is what is something that is already there. Though it is more concentrated in main cities like Delhi and then Chennai, Mumbai, and these bigger cities have solutions for fast charge. So it will be still slower than the partners 15 minutes for charging. This will be around 1 hour or something. So that is the third solution we can say, which will be, again, all of these are in parallel to the slow charging solutions, because again, as everyone knows that electric vehicles, if the battery cannot be charged, the vehicles cannot be used. So it is very much important that there are as many maybe ways of charging for one vehicle with multiple standards, whatever multiple ways of charging, that makes sense. Now coming to the swapping, so before swapping, I would say initially, so when we made a bigger battery pack as per our requirement, bigger means bigger than what was readily available. So we had to make that, because before that we were working with already available battery packs, which was a parallel pack combination. So why I say that, because for 3-wheeler, again, because of the weight constraints and all, it is not possible to have a single battery pack that can be swapped. So it has to be a parallel combination. Roughly, I think it will be either 3, 4 or 5 batteries will be required. So we actually there were instances where we tried based on, again, customer requirement. If customer asks that you go look for a swapping solution, definitely we would look into those. But at the end of the day, none of them materialized for various reasons. But conceptually, we always think that battery should be a single battery pack, what we are working with a single BMS, which is controlling all the cells which are in those batteries. Because in the end, any battery is as good as the weakest cell that is there in the batteries, because that will directly affect the range that you are getting from the vehicle. And for vehicles, since we are carrying that additional weight of the battery, if that weight is something that we are not using, it is just eating up the so for example, logistics company, it is eating up their business space is what I would say. So the money that they will take from that. So in short, our still focus would probably be inclined to fast charging solutions, but it would always be in parallel to the slow charging availability, overnight charging, which we can say.
All right. And just a follow-up question, Prathamesh. Is there a scenario where your customers have like fixed routes and a proper planning can be done where they know, all right, this is my route and I can stop it after 25 kilometers or 70 kilometers and then get a fueled up or swap? Is that the scenario with?
Correct. So again, I think Mr. Sathe can tell better, because it is more, they are the customers. Because so normally for all these fleet operations and all, so it's pretty much, I believe the route is quite fixed what they have to do. There is always a time in between loading, unloading. So there are multiple places wherein top-up kind of charging can be done, or even fast charging solution per se is useful. Even if it is limited to cities, it is still useful so that quickly they can just top it up, continue from there, and in the end, overnight charging will always be there, because again, depending on power outages and all of that. Absolutely. So it makes sense that we have a slow charging solution as well.
All right. Thank you so much for that perspective, Prathamesh. Shashank, I'll come to you because you're the customer. So if you can help us understand, like Prathamesh talked about fast charging as a solution in parallel to slow charging, but when it comes to fast charging, I think there are a lot of questions around, do we have the right infrastructure, reliability? Do we need to invest in separate infrastructure to make that work? What has been your experience so far while dealing with fast charging? Any challenges that you have faced that you can share?
So I will fully agree to what Prathamesh mentioned, right? So there, by and large, currently the 3-wheeler and 2-wheeler space, which is using EV vehicles, right?
Correct.
Out of 3-wheelers, large chunk is being used for the logistics business.
That's right.
The government is giving more and more benefits to the freights and cargo operators who are operating purely on EV business. Now, by the very nature of how logistics business works and the range, or as we call it in EV terms, payload, and payload is basically ability of taking number of pure numerical kilograms or tons of weight that particular vehicle will carry.
That's right.
And haulage is the distance point A to point B in which it can most efficiently go. Right now, there are various challenges around these workflows. Essentially, as you mentioned, a vehicle that has run out of juice will just not budge. Right? It will be right there, stand still in the middle of the road.
Correct.
You will have to push it across to the side and then figure out a way of making it move. Yeah. Right? So that by that very nature, the paranoia that most EV owners, and I'm speaking for all, I mean 2, 3, 4-wheelers, whatever, is that they always keep an eye out on the battery. Right? Now, keep EV vehicles aside for a minute. I'll just allude to our cell phones. Correct? The devices that have been surgically attached to our bodies for last couple of years now, we are paranoid about not running out of battery for something as silly as a mobile phone, right? Imagine what your paranoia will be if in case there are 4 occupants in the car, or there is goods worth of couple of lakhs at your back and the guy has to reach at some point. or if there is a passenger for a rapid go or somebody who is sitting at the back and needs to reach some destination, right? So, point I am making is fast charging is good if in case there is a time-bound urgency to reach a destination. But fast charging by its very nature and the current technical space in which batteries are available is not that great for a battery itself.
Okay.
Correct? A slow charging protocol will always make you have a longevity of that battery retained over a longer period of time. And hence, most operators these days continue to put their vehicles on a charge. We call it depot, correct? So you park your vehicles at depot and you charge those overnight over a steady, consistent, standard charge, so that vehicle is out for delivery next morning. And most logistics business operators operate probably 2 shifts a day, right? So logistics business for 3-wheelers typically starts at 4 a.m. and that shift gets over at 2 p.m. and the next shift starts around 4 p.m. and gets over at 10 to 11 p.m. If you notice, that's the time when you often get all deliveries from Amazon, Flipkart's, Mother's Recipes and whatever. Correct? So that's how they operate. Which means whatever charging interval you have for your vehicle has to fall between these 2 time slots. The time slot in the noon is ridiculously short, not even 1.5 to 2 hours, because that's when unloading, loading happens. The time slot in the night is longish, and hence you put your vehicle, let it calm down, let it get fully charged, and then you move. So that's how it works.
That's brilliant. No, thank you so much, Shashank, for sharing that. And you know, this all again brings down to what you and Prathamesh said, that ultimately everything boils down to the battery, because that's the core component of your car, and its battery's health is extremely important and charging is rightly proportional. So, Akshay, if I may ask you, I think 82 volts is providing a lot of data, insights, and enterprise solutions. Can you talk a little bit more around what kind of data sets, you know, when you plug your charger into a battery, you know, how that exchange happens, and how are you leveraging that to inform some of these charging behaviors and battery health issues?
Okay, so when a car or a vehicle is plugged in, a lot of data gets exchanged, and in a DC charger, the data volume is far more than an AC charger. So for example, if the battery is hot, let's say it should be at 60 degrees, but it's at 70, the charger will take a call not to charge at full speed of the capability of the charger, right? This is a small example of how data works in improving your the longevity of your car and the battery. But overall, data can be used to fix locations of chargers, right? Where are the maximum EVs plying? Maybe put a fast charger there. The speed of the charger in a location can be decided by the volume of cars passing through that point. A lot of places, if we start using data, the EV ecosystem will start mushrooming faster than it is today, right? But it's important that we hustle today to get to a certain critical mass and then use the data which that critical mass provides to build on further. We not started getting any insights yet, it's too early. We're just collecting the data collection phase right now.
And are you seeing a lot of excitement about these services from your users'
Absolutely.
perspective?
All enterprises want to talk about sustainability and how data is improving their sustainability actions. So, I mean, there's a lot of excitement the moment you say, hey, I'll set up an EV charging network for you and collect data from it. They want the data. They don't care about the chargers.
Interesting. Yeah. All right. And I have one more follow-up question, Akshay, for you. In terms of utilization of charging infrastructure, because that's one of the, and maybe Shashank after Akshay, if you can also comment on that, because that's one of the biggest investment question, right? Is my asset going to sit idle when I'm going to have the break even? And are there any other value streams or revenue streams that you foresee, you know, investors can explore beyond the electrons that we are selling?
So today, a large PSU energy company, which have installed about 700 DC fast chargers, their average utilization about 7.5 minutes per day, right? And they've spent a few 100 crores in setting up this network, right? But it works very organically. They reach out to their franchisees and say, look, do you want to put a charger? I'll give you so much, blah, blah. That will not work going forward, no? So how utilization can be improved? Again, use data. And like I said, you have to go to places where an individual will be there for a longer period of time, either at his workplace or at the place where he stays. Today, apartments pose a slight bit of a challenge with respect to putting EV chargers because the power, the load capacity of the building is set. It's very difficult to increase it. But workplaces are excellent avenues for putting up chargers. Yeah, I think so. Data will improve. Time is up.
All right, sure, absolutely. So maybe I have a question. If any of you would like to comment on which we were, talking around renewable-based charging. And somebody asked a question: you can launch EVs, but if it is charged via coal, it's as fossil as any other asset. Would any of you like to comment on that? That how are we seeing some of the RE-based charging solutions, or we don't really need to talk about it because at a central level we are moving towards renewable energy. So how does it matter? What's your view on that?
So that's what I think. Renewable energy usage. It's a parallel topic that has to go on in parallel to electrification, because electrification, in the end, at this point at least, it is the batteries that are being used, and those are charged from certain source. That source
Correct.
can be renewable based. It can be fossil fuel based or whatever, depending on the availability. That's what it would be. Definitely, it makes sense if more and more wherever there are charging infrastructure, if at least those are moved to renewable energy based, I think it makes more sense there, because it will be a continuous utilization. See, one more thing about renewable, which is what I think is it. Most of the times it may require a energy storage, because that's not the usage pattern and all is not consistent. So it may be there is a energy storage requirement. So if there is any places like charging stations or places like that where there is continuous usage, see, because every conversion of energy, there is a tax that needs to be paid in terms of efficiency and all. So it's in the end that is a loss. That is loss to the system, because even those minor losses is what we should probably think about in the bigger picture, because all these smaller losses, when they add up, no, so then it becomes much bigger than a sudden big thing that you see.
I have a point to make. So, power generation will get distributed. I mean, captive
Correct.
locations will start producing their own power. With that, the losses he talked about will keep on reducing, right? So, if you have a EV fleet or your employees have EV cars and you produce your own power, that's the perfect situation. So, I think more and more buildings will get greener by nature because they have to get certified.
Correct.
So,
Awesome. All right. So time is up, but as we close, I think any final closing comment? We have a lot of entrepreneurs and startups and established firms. Any closing comments from you on the charging infrastructure, or how we can just make this a reality and accelerate?
very, very early in the EV ecosystem, whatever you do, if you just keep innovating, you will make a difference for sure.
Okay.
Yeah.
Makes sense. Shashank?
I think innovations, the entire EV thing is, actually the point of influx is innovation in the battery space itself.
That's
So reducing load, increasing the range, and reducing the timings of charge and longevity. I think once
Those
we
are
get
the
that,
differentiators.
we are good.
Thank you. Prathamesh?
Yeah, definitely. Means for the considering battery technologies, I still think there is a lot to be explored, because a lot of things today are based on, at least health related information is based on simulation data or accelerated test data. That is a good starting point, but eventually all the data collection that we are doing through the real world scenario, so always we need to go back, have comparisons with what was starting similar, keep on correcting those things to make sure that in the end there is not the depletion of batteries are limited. So there is for all this, there is no shortcut for this. Basically, it's not something that quickly within a couple of months you would understand. So that kind of patience would be required. Because it's a new technology, of course. So it's not something that. So we have to be patiently keep watching, going back and forth between the things. So there's a huge opportunity for research.
Yeah, so the consensus in one line is keep innovating, keep trying, keep failing, and then again keep trying, right? I guess that's what all the panel members suggested. So on that note, I think we would like to close it. Do we have time for Q&A or?
Yeah. Delegates, any questions? Kindly raise your hands. Yeah.
I have a question mainly regarding the battery swapping. Will that be limited to two-wheeler, three-wheeler, or it will also go to the heavy vehicles? Because we also said that slow charging versus fast charging, and I heard fast charging is not good for the vehicle, health. So then in that case is the battery swapping is the one. So because considering the weight of the battery and other.
Correct. So my personal opinion is, but again, I think we need to see it, how innovators innovate on that aspect. But my personal opinion is two-wheelers are something, those are at this point, that's where it makes more sense, because for the lighter weight of batteries that and it can be a single, because again my preference would not be to have parallel batteries that needs to be used in some system, because again it is the weakest link out of the parallel pack. The performance will be similar to that in the vehicles scenario. So I would limit it at two-wheelers kind of. Even three-wheeler battery weight is around 120-130 kgs, which again a single battery pack swapping it's not an easy task.
Correct. And also to add to what Prathamesh is saying, unlike internal combustion engines and cars that run on ice, there is a direct and immediate impact of how you drive an electric vehicle. I mean, if I don't have an EV, but I have driven one couple of times, and the nature in which I drive, if I drive aggressively, and there is more alluding to automatic transmission cars, right? If you drive like a maniac, you will have ridiculously low average or mileage that you get. Likewise, it is for electric vehicles. If I drive aggressively, my ability to carry payload from point A to point B reduces surprisingly, and it's astonishing. It is that bad, right? So one has to be very composed. I call it a retired pensioner kind of driving. So just keep driving at a speed of 60 kph, ignore everything else, you reach your level of zen and just continue to roll on the road. I think that's how it will be. But otherwise, the current paradoxical statement is that yes, fast charging is not that great for batteries, but there are many companies who are doing R&D. So for example, there is a liquid electrolyte, a lithium ion and nickel battery that is being developed by a couple of Japanese. This is supposed to be hitting market in 2027. But it is expected to have 1,000 miles range and supposed to be fully charged on not fast charging protocols in 2.5 hours. And on fast charging, 0 to 80 is going to do in 20 minutes. But that's, all these things are on paper, right? I mean, to quote Jeremy Clarkson, when I heard in my teens, hydrogen fuel cell, we have been reading about it. The knack is not to convert that vehicle to a hydrogen bomb and make it run safely on the road. So that, I think that's what it is.
That's a good point. All right, one final question.
Yeah. Okay. I just wanted to know whether now, as of now, the vehicles go to the charging stations, the fuel cells are with the vehicles, and the charging happens, because of which the vehicle is stationary for 2, 3, 4 hours, whatever.
Correct.
I am saying, why can't the cells be charged at the charging station itself, and simply when the vehicle comes at that station, the fuel cells are pulled from there and put it here?
So that is what is the swapping solution. I think swapping solution is the same thing.
But my query is like, I mean, how long is going to take, and why can't we have a standardization of this? I mean, how much time it will take, and if at all when it happens, what will happen to the existing technology? Which, like, as of now, it's not, swapping is not happening, right, in India. So when this happens, what will happen to the existing vehicles? What about the owners who already have EVs?
I think my observation is, and maybe some of you can correct me, there'll be no one technology, whether it's charging on EVs, that will dominate the industry, right? Whether it's EVs, hydrogen, biofuels, flex fuels engine, CNG. I think the whole decarbonization of transport will be led by multiple technologies. Of course, there'll be one which will have a bigger market share. The same goes in charging infrastructure. So to your point, if swapping comes or if this technology comes, what will happen to the current set of vehicles? I think there'll be infrastructure available for them to go through their life cycle eventually, and then there is a question of upgradation. So to be honest, I think where we are sitting today, I don't think that is a risk that anybody is thinking or even talking about, because all these technologies are gonna take, like I think Shashank and Akshay were mentioning, it's 5, 7, 10 years, gestation periods, right? Eventually, then we are going to see becoming more commercial. So to summarize, no, there is no such risk that we currently see. When it comes to swapping, I think Prathamesh, you were commenting.
So that's what one thing is, legacy will always be there. We cannot say that all the vehicles that are on the road, we are going to swap it to new technology. So legacy will always be there, and definitely we can't just stop using those vehicles which are on the road. So that's what it would. All of these would be curves that will be going up, and then that technology will come down and something else takes over. So it will be smoother. It won't be a overnight kind of transition wherein we just need to throw away things that are already there.
Are you looking out for some timelines?
I'm so sorry that we need to move ahead. Thank you so much for your questions, delegate. And it is triggered a lot of like what you said. It keeps on evolving, and the technology is still we are waiting what's coming around the corner. Thank you so much for engaging in this interaction.